Have you ever wondered which metal is the true champion of electrical conductivity? Every day, billions of people rely on electricity delivered through wires made primarily from two materials, copper and aluminum. These two metals power our homes, industries, and entire cities, but they each have very different strengths. So, if they were to compete head-to-head, which one would come out on top? To answer that question, we first need to understand what an electrical conductor actually does. Its job is to allow electric current to flow with as little resistance as possible. Lower resistance means less energy is lost as heat, making the electrical system more efficient. While several metals can conduct electricity, copper and aluminum have become the world's most widely used conductors because they offer the best balance of performance, availability, and cost. Copper has long been considered the gold standard for electrical wiring. In fact, among common metals, only silver conducts electricity better. Copper's atomic structure allows electrons to move with very little resistance, making it incredibly efficient. For the same wire diameter, copper carries more current, generates less heat, and delivers more reliable performance. It's also highly flexible, allowing electricians to bend and install it repeatedly without damaging the conductor. These qualities have made copper the preferred choice for residential wiring, industrial equipment, electric motors, transformers, and electronic devices. Aluminum, on the other hand, approaches the challenge from a different angle. Although it conducts only about 61% as well as copper, it weighs roughly one-third as much. That means an aluminum conductor must be thicker to carry the same electrical current, but even with its larger size, it remains much lighter than an equivalent copper cable. This enormous weight advantage makes aluminum ideal for overhead power transmission lines stretching hundreds of kilometers across mountains, forests, and cities. Using copper for these massive electrical grids would dramatically increase both construction costs and the size of the support towers required. Cost is another major factor. Copper is significantly more expensive because it is less abundant and requires more intensive mining and refining. Aluminum is one of the most abundant metals in Earth's crust, making it far more affordable for large infrastructure projects. For utility companies building national power grids, these savings translate into billions of dollars. However, aluminum isn't perfect. One of its biggest challenges is oxidation. When exposed to air, aluminum quickly forms a thin layer of aluminum oxide. Unlike copper oxide, which remains reasonably conductive, aluminum oxide acts as an electrical insulator. If this oxide forms inside electrical connections, resistance increases, generating heat that can eventually damage the installation. Aluminum also expands and contracts more than copper as temperatures change. Combined with a phenomenon called creep, where the metal slowly deforms under continuous pressure, connections can loosen over time. Loose electrical connections create additional resistance, increasing the risk of overheating and, in severe cases, electrical fires. For this reason, aluminum installations require specially designed connectors, proper installation techniques, and regular maintenance. Copper avoids many of these issues. It offers superior mechanical strength, excellent corrosion resistance, and far more stable electrical connections over decades of use. That's why most building codes around the world still recommend or require copper for residential wiring. Today, engineers don't view copper and aluminum as rivals with a single winner. Instead, they see two specialized materials, each optimized for different jobs. Copper dominates inside homes, offices, hospitals, and factories where reliability, durability, and safety are essential.